have to admit that it's a lot of fun when people ask me what I do for my job because I tell them I literally rub things together. This sounds ridiculous. Just rubbing things together. But it has a technical name. Tribology. Tribology. From the ancient Greek word tribos, which means to rub. It's a funny-sounding word you've probably never heard before, but I promise you, discovering it changes your experience with the physical world. Tribology has given me amazing projects. I've worked on materials that fly, and I've worked on dog food. A combination that doesn't sound like one person has any business doing in the span of just a couple years, until you start to view the world through a tribological lens. And I think you'll be surprised at how significant a little bit of tribology can be in alleviating some very large problems. Tribology is the study of friction, wear, and lubrication. You have all experienced all three of these things. Remember the last time you tried to move a heavy object across the floor and you could just feel something resisting you? That would be friction. Friction is the force that opposes motion. Wear is the loss or transfer of material. It's the reason you have to replace your favorite shoes because eventually the soles disappear. Lubricants are used to reduce friction and wear. They loosen up those stubborn, rusted bolts that just otherwise will not budge. But tribology is also defined as the science of interacting surfaces in relative motion. So, interacting surfaces in relative motion. There are a lot of those in the world. As you're sitting there right now, are you wiggling your foot at all or maybe shifting around in your seat? Because guess what? Tribology is happening. Even the smallest shift in your seat involves two surfaces moving relative to each other. And your tribological interaction for the shift will be different than the person next to you. This is because the clothes you're wearing change the friction between you and the seat. If you're wearing silk, it's a little easier to squirm around in the seat than if you're wearing wool. That's because the friction is lower for silk. If you're moving your ankle or wiggling your ankle at all, did it make a popping sound? You've had that, right? You get up, you move around, and some joint cracks or pops. Thank you for that sound, tribology. That sound can come from the fluid that lubricates your joints just moving around. You're essentially releasing gas bubbles in that fluid. That sound can also come from the tendons simply moving over each other. Pretty common in the ankle, so any of my fellow footwiggers out there may suddenly find themselves curious about the tribology of tendons. But how does one become a tribologist like me? It starts when you're a kid, of course. I was a ballerina growing up. I reached a level where I was dancing on my toes or on point. But when you're dancing on point, you're wearing those amazing shoes, but they can be slippery on the stage. The last thing you want to do when you're trying to dance on your toes is to slip and fall. So we had boxes of stuff called rosin. We would step into the rosin, put a light coating on our shoes. Rosin comes from tree sap, and in its powdered form, makes things less slippery. You learned real fast as a dancer how much was the right amount to put on your shoes, because if you didn't put enough on, you're probably going to slip due to the low friction between your shoe and the stage. Best case scenario, you're the clumsy ballerina on stage. But the worst case scenario would be an injury. Already, I was optimizing and manipulating friction. You see, I was destined to be a tribologist. But you were also a junior tribologist. When you used crayons or colored pencils, you knew that the harder you pressed, the darker the color. You also knew that this meant you were going to have to sharpen that crayon or colored pencil more frequently because it was wearing down faster. Now let's talk about those enticing, shiny waxed floors that you just had to slide across. You knew if you put on a pair of socks, you were going to get a really good slide across that floor. Good luck trying to do that barefoot. Master manipulators of friction. All kids are tribologists. What about us as adults? At some point today, you brushed your teeth. I hope. This is tribology in action. The toothpaste and toothbrush are working to remove or wear the plaque from your teeth. For the record, my dad is a dentist. Never thought my career was going to circle back to the family business. But one day, we found ourselves speaking the same language when I was tasked with developing a test to investigate plaque removal. Sounded simple enough? until I started to look at it as a tribologist, and then it became incredibly complex. You have hard materials, those would be your teeth, soft materials like your gums, the toothpaste, the toothbrush. There's lubrication in the form of saliva and water, the dynamics of the person doing the brushing, and more. I promise, if we put diamonds in your toothpaste, you're going to remove that plaque. Probably going to remove your teeth as well. So there's a fine balance to be had between wearing the plaque away and not damaging your teeth and gums. We're brushing our teeth because we ate. Eating is another routine thing we all do. Seems simple enough. But it's another field of tribology, and it's not so simple. You have the food, which will break and wear while you're eating, and that food is interacting with your teeth, your tongue, your saliva, your throat, and all of those interactions are going to influence your experience of eating. I think you can all recall a moment where you tried something new, and you just found yourself going, well, it tastes all right. I really don't like that texture. Tribologists are looking at lubricity and coefficient of friction as ways to connect mouthfeel and texture to what you're experiencing. So that if we're changing the formulations of what we're eating and drinking, so the sugar content or fat content are different, how does that change mouthfeel? How do we quantify that? This is what tribologists are looking to solve. And while my colleagues were in one corner of this lab looking at the fat content of yogurt, I was in another corner studying dog food. That lab smelled really good, by the way, let me tell you. We all brush our teeth on a regular basis. How many of us brush our pets' teeth? Animals as adults commonly get periodontal disease, so we really should be brushing their teeth. And more pet owners are starting to do this. I know my best friend is really great at brushing her cat's teeth somehow. Good luck trying to do that with my cat. So what pet food suppliers are trying to do is incorporate plaque removal in things like treats. If you have a dog, you may have observed that you give your dog a treat and it magically seems to disappear after just one bite. So the added challenge here is, how do you remove plaque when you have one bite? I developed a benchtop test to study this problem, and to do so I had to mimic the oral system of dogs. Their teeth, plaque, saliva, and I used friction and wear measurements to study the effectiveness of that treat on removing plaque. If you're sitting there right now thinking about the last time you didn't brush your dog's teeth, you're very welcome. But what's the big deal with tribology? Let me give you one more example. No matter where you are right now, you got to this location somehow. Maybe you walked or rode your bike, but for most people in this room, you probably came in a car. Just think about all the tribological systems in a car. You have your personal interactions with the car's interactions with the road, and then everything under the hood and in the drivetrain. Some routine maintenance is directly connected to tribology. You know how many miles your tires are recommended for using before you replace them. You regularly check the treads on those tires. You're actively monitoring the wear of your tires. Tribology is the study of wear and friction. And with tires, friction can be the difference between a safe arrival and a car accident. This is because the friction between your tires and the road will influence your acceleration, your deceleration, and your stopping distance. As a driver, you instinctively already know how important friction is because you know when the roads are wet, they're more dangerous because they're slippery. This is because the water is reducing the friction between your tires and the road. You may recall that friction is the force that opposes motion, so water reducing that force means it's now easier for you to move. Hence, it's more slippery when the roads are wet. Something else to consider is that overcoming friction takes energy. So you're losing energy to friction. This is one way your tires can influence your fuel efficiency. And in fact, did you know that about 1/3 of the fuel that you put into your internal combustion engine vehicle will be spent overcoming friction? 1/3. Tribology research has helped us reduce friction and therefore increase fuel efficiency and reduce emissions. Holmberg and Erdemer have actually done some great studies showing the impact tribology research can have on reducing our energy consumption. And they found that looking over the span of 20 years, we had the opportunity to reduce the energy consumption of passenger vehicles up to 60%. We think about all the cars in the world, it's a lot of energy we can save. It's part of the nearly 9% of our current global energy consumption that the authors identified tribology can help us save. That's a significant amount of energy, so when you look at the numbers, tribology can do some amazing things. My colleagues have identified up to 20 quads of energy we can save across the US alone. To put this in perspective, 1 quad of energy is roughly equivalent to 180 million barrels of oil. And tribology can help us save 20 times that. This is through new materials, new lubricants, novel component design, doing things like making wind turbines more efficient and reliable. This happened just by putting 31 people in a room who viewed the world through a tribology lens. Imagine the opportunities that will reveal themselves as more of us start to see tribology all around. My favorite projects right now are in aerospace applications. I love reducing wear and friction in these challenging environments. I can make materials and parts that will reduce the friction in moving components and engines so that they have less force opposing their motion. Less force to move means they require less power. So you can use a smaller actuator, which would weigh less, which saves fuel. I can also help make parts that last longer through lower wear. This will reduce material waste and also means we're manufacturing the parts less frequently, so we're saving energy in manufacturing. I encourage you to start seeing tribology in the world around you and to think about how you would improve those interacting surfaces you experience. Even the smallest improvements really add up. Tribology may be a funny sounding word, but it has a huge impact on our world. Thank you.